Hi guys, this is Mrs. Allison, and today we are going to start our unit circle. So hopefully you have this sheet printed off because we're going to use that. But before we do, we are going to go back to what we did last week with the special right triangles. And I have two special right triangles. They are pretty small. Let's see if I can zoom in on them just a little bit. Let's bring that down. Okay. So they are fairly small special right triangles for now, and I'll show you why they're so small to begin with. But we are going to solve these special right triangles as if the hypotenuse is 1, okay? So we're gonna make this hypotenuse 1, and we are going to go through and solve this unit or this special right triangle. So remember that we have the ratio for a 30, 60, 90. I'm gonna move this one. You see that's a 30, 60, 90. And on a 30, 60, 90, remember the 30 side is S. Ooh, that doesn't show up very well. Let's try a different color. Let's do purple. This side is S. This side then is S root 3. And remember the hypotenuse is 2S. Remember these come from an equilateral triangle. And so if I want to solve this, I'm going to solve this by setting up the equation 1 needs to equal 2S. Which means that my side is 1/2 when I solve for that. So that means this side is 1/2. And then my long side, my long leg, is going to be 1/2 times root 3. We would probably write that root 3 over 2. Okay, so this would be root 3 over 2. How do we feel with that? Feel good? Okay. So I'm going to label this triangle that we have right here. And I'm going to label this side 1, and you'll see why I'm doing this in just a minute. This side 1/2, oops, and this side root 3 over 2. Okay, so there it is. And now let's look at the 45, 45, 90. And if you remember, let's see here. Let's see if I can adjust the camera. If you remember from the 45, 45, 90, that this side is S, then this side is S, and this side is S root 2. So this one's actually going to require a little bit more work to solve. So if we assume my hypotenuse is 1 again, then I know 1 needs to equal S root 2. Okay? And if 1 is going to equal S root 2, to solve this, I need to divide both sides by root 2. So we get that S equals 1 over root 2. The problem with this is I can't have a square root in the denominator. So remember, we use the process called rationalizing the denominator, where I'm going to multiply both top and bottom by root 2 over root 2. So we get root 2 over root 4, which is just 2. So I know these two sides are root 2 over 2 and root 2 over 2. Okay, feel good so far? So I am going to label this triangle here. If this hypotenuse is 1, then this side is root 2 over 2, and this side is also root 2 over 2. And then would it be okay with you if I bring in a third triangle, and you'll see why these come into play. If I bring in a third triangle, okay, I'm going to move that down right here. If we look at this third triangle, do you see how this side is 60, 90, which means that would be 30? So are you okay if I go ahead and label this based on what we did on the 30, 60, 90 up here? Because these sides will be the same. So if my hypotenuse is 1, the side across from my 30 would be 1/2, and then this would be root 3 over 2. Do you feel comfortable with that labeling? All right, perfect. Okay, so now we're going to take these 3 triangles. Now you don't have this to do. With yours, you're going to use your unit circle. Okay, let's see if I can get this into the screen a little bit better. Let's just zoom out. How about that? Oops, that'd be in. Okay. Okay, so you have this unit circle. Now the reason I made my triangles as small as I did is because they fit perfectly on this unit circle. So remember I told you that the special right triangles play very nicely into our trig units. So look for me, or look with me at this right triangle. And we just got done talking about angles and radians. We'll get to that in a moment. Right now, I'm just going to deal with degrees and what it means on the unit circle. Okay, so a unit circle is so called a unit circle. And I'm just going to write this here because it means that my radius is equal to 1 unit. Whatever the unit happens to be, my radius is equal to 1 unit. So using that on the unit circle, let's picture this. Now this unit circle is on a quadrant system. It's on a graph. So notice here, I'm going to write 0 degrees. This is 0 degrees right here because the angle, if this is my initial side, my terminal side hasn't gone anywhere. And do you agree with me that this ordered pair would be 1 for x and 0 for y? That's because this radius right here is 1. Okay, using that same idea, if I look at my quadrant right here, do you agree with me that this would be 90 degrees? Okay, well, if this is 90 degrees, do you agree that the ordered pairs would be 0, 1? 0 for the x, 1 for the y. All right, moving on. If I keep going, do you agree with me that this is 180 degrees? And then my coordinate would be -1, 0. Okay, keep going. If we go further around, this measure right here would be 270 degrees. And the coordinate would be 0 for the x and -1 for the y. Okay, this is what makes up a unit circle. Now the other pieces that go along with this all come down to these special right triangles. Everything in this unit circle is made up from the quadrants that we have here and then the unit circles, or sorry, my goodness, the special right triangles. So here we go. The first one we did was a 30, 60, 90. So I'm gonna just set this right here. What does that look like? That's a 30, 60, 90 degree triangle with a radius of 1, which is equivalent to the hypotenuse of the triangle. Now, why is that important? Well, that's important because that allows me to see what my x and my y values are. This angle right here is 30 degrees because from the initial side to the terminal side is 30 degrees. Do you see it? And what I know is that this length right here is the x value, and this x value is √3/2. So I'm going to write that in my ordered pair. This will be √3/2. And then my y value is going to be 1/2. Okay, do you see that? Great. I am going to continue adding on to this. Well, the next one we did was a 45, 45, 90. And look at that. That 45, 45, 90 with the hypotenuse of 1 fits very nicely right there. So then what would my ordered pairs be for this 45, 45, 90 degree triangle? Well, the x value that we have has gone over √2/2. And then the y value, let me write that, has gone up √2/2. So you can see the x and the y value have gone up and over √2/2. They're equivalent. So this is my 45 degree angle. My terminal side is at 45 degrees. I bet you know where this is going. So the next triangle that we have is my 60, 30, 90. We're going to say that because the 60 is the first angle we want. And if I put my 60 degree angle right here, what you'll notice with the hypotenuse of 1 is that my x value now is 1/2 and my y value is √3/2. So my terminal side is at 60 degrees. Yes, this other angle is 30, but that's not an angle in standard position. So it's not on the x-axis or starting on the x-axis. This is 60, 45, 30. Okay, how do you feel so far? We'll get to the radians. Those are the other blanks in a little bit, but we're going to start there. Okay, here's what I want you to notice. Remember we've talked about reference angles? Okay, we said a reference angle was the closest angle to the x-axis. I want you to watch for just a second. What if I take all three of these and I just mirror image it. What do you notice? It lines up exactly with those points. So what I know is that the triangles that were here, let's see, this was blue, and I'm a visual person, you know that, oops. This is blue, and then this triangle was yellow. Right? And then this triangle was pink here. Do you see that they're mirror imaged? So guess what that means? It means all their ordered pairs are also mirror imaged. Now the degrees are going to change, and we'll talk about that in just a minute. But do you agree with me that the x value on this pink triangle will still be 1/2? It's just going to go in the negative x direction because this is where x's are negative. And the y is still going to be positive root 3 over 2. Okay? Then do you agree with me that the x here is going to be a negative root 2 over 2 and the y is going to be a positive root 2 over 2? Do you agree? And then here, I'm not sure why I keep closing all these pens. Let's just leave them open. Here, the x value is going to be a negative root 3 over 2 because it's in the negative direction, whereas the y is going to be 1/2. How do you feel with those ordered pairs? Okay, let's talk about the degrees of the angles. Okay, do you agree with me that if this is 60 and I continue on and if this reference angle here is 60, how big is this angle? Well, think about this. This is 180. This was 60. What's left over is 60, which means this angle has to be 120. 160 with a reference angle, another angle going over 60, we get 120 degrees. Which means that this angle that we have right here will need to be, we have 45 here, goes to 90. This is a reference angle of 45 that ends at 180. So this angle has to be 135. Do you agree? Okay, keep going. My blue triangle here needs to be an angle of, well, a reference angle of 30, because that's what this angle is, which means that 30 less than 180 is 150, 150 degrees. What do you think? Okay, let me show you, oops, that should have been in blue. Let me show you an easy way to remember these angles, okay? Yes, this is a right triangle, so these match, but I can show you an easy way to remember the degrees as well. This was yellow. So that was that triangle there. And then this was the pink triangle, and we'll come back to the radians in a minute. Okay. If you notice that if this angle's 30, and I don't count the middle angles, I have 30, 60, 90, 120, 150, 180. So I have all of my multiples of 30. And if I don't count the pink and the blue, and I start here, I go 0, 45, 90, 135, 180. Those are all factors of 45. So those are all reference angles of 45. So let's keep going. Any guesses as to what's going to happen here? Well, if you guess that these are still the same triangles, just mirrored this way now, you would be correct. And if I look at their ordered pairs, and I'm in this third quadrant, well, I didn't get that one on very well. If I'm in this third quadrant, what are the ordered pairs going to be? Well, the x's are negative and the y's are negative. So since they're both negative, these are going to be the same ordered pairs, just both will have a negative sign. So it'll be negative 1/2 root 3 over 2 for the pink. It will be negative root 3 over 2, 1/2 for the blue. And then it will be oops, that should be a negative 1/2. And then it will be negative root 2 over 2 and negative root 2 over 2 for the yellow. Do you see how that's built? Okay, I want you to pause the video and I want you to see if you can do the next quadrant while I fill in these degrees. Okay, so if we look at these next quadrants, do you agree that this is now just going to be the mirror image again, or the flip of this one? So I still have these same, let's see, this goes this way, these same special right triangles. This is why I said special right triangles are so important for the unit circle. I have the same special right triangles happening here. So let's use the idea that the x in this case will be positive, but the y will be negative to fill out our ordered pairs. So this blue one is going to be root 3 over 2 and negative 1/2. The yellow one is going to be positive root 2 over 2 and negative root 2 over 2. And then this pink triangle is going to be positive 1/2 and root 3 over 2 negative. How do we do so far? Okay, now my degrees. Remember, every pink triangle that we have has a factor or a multiple of 60. Every blue triangle and pink triangle has a multiple of 30. And then every yellow triangle has a multiple of 45. So if I'm going to go 30 degrees more than 180, this is going to be 210 degrees. And if I'm going to go 45 more than 180 to get to the yellow triangle, 45 more than 180 is going to take me to 225. My pen's over here, 225 for this angle. And if I go 60 more than 180, using my reference angle, 60 more than 180, this triangle is going to be 240. Okay, moving over here, and I'm not going to color those just yet. If this is 270, then this one is going to need to be 300. And then the middle one is going to need to be 315. And the top one is going to need to be 330 degrees. So this is my unit circle. This is how the unit circle gets built, is by special right triangles. Now I'm gonna film one more video that talks a little bit about the radians and then what these ordered pairs mean and why we use them. So we'll see you in the next video.